Well, hello again, and welcome to the VK6CS Amateur Radio channel. I just thought I'd do a quick clarification of what I showed you in the previous video. Exactly what is that interface relay doing? Okay, well, inside the FT450, these modern radios, or certainly the ones I've come across, don't have a relay as a PTT line on the output. It's not what they call a voltage-free relay contact, meaning you can put any polarity voltage you like on it and it will switch it. The FT450 has a little NPN switch, which is just a little NPN transistor, like that. The collector goes out to pin 2 on the linear socket. Inside the radio, that goes to the chassis, like that. And fortunately the clever guys at Yaesu have considered that there's probably going to be some interfacing required at some point, or there may be, because they have provided a fused 13.8 volts output on pin 1. And I thought, wow, that's really useful. Now this PTT line switching transistor has a protection diode across it, which is terrific, like that. Because if you put a relay across here, when the relay drops out, there could be a back EMF, there could be a voltage generated by the physical movement inside the relay coil. And the peak voltage might be enough to damage this transistor. So what they've done is they've put a diode across that like that to just shunt that to ground and get rid of any back EMF from the relay. And excellent, great stuff. However, if you've got an ancient antique linear amplifier and the keying line for that amplifier is a negative voltage, as it is with the FLDX 2000, they just derive that. It doesn't really matter what the polarity is if you're switching it with a relay. They derive that that switching line in the amplifier from the valve bias supply, or the tube bias supply, and it's about negative 18 volts. So if I put negative 18 volts on there, not going to bother this. This won't conduct, but it won't bother it. This, however, will represent a short, and it will go up in flames. I don't quite know why I felt the need to say that with a French accent, but this would be a dead short, a nail to a negative voltage coming in here. So very bad idea to hook that negative PTT line up to that point, because I really wouldn't fancy digging around in my FT450 and replacing this. Okay, so what did I need to do? I take the 13.8 volts out and I run that into that little 12 volt relay that was on the blue bit of plastic. And the other side of that relay coil I then take back to pin 2, like that. And these were the two red wires in the previous video. This also has a protection diode across it. Like that. And that will kill any back EMF. This is just a bonus, really. If that's not there, this will do the trick to protect the switching device inside the FT450. Remember, this is inside the FT450. This is my little blue relay on the plastic base with the plug-in protection diode module. And of course, if you're going to do this, you have to make sure that you get the diode the right way around. Otherwise it will conduct, otherwise it'll turn hard on and your 12 volts will go straight through the diode, straight down here, and as soon as you key it, this thing's probably going to go pop. Or it may well go up in flames. Of course, this might be of a suitable rating to prevent that from happening, as long as you derive your 13.8 volts from within the radio. Right, what happens then? I hear you cry. Well, what happens then is there's a relay contact here, like that, and that goes to the linear amp. Now, on the linear amp, you've got something called, there's a terminal screw mark relay, and ground, and that goes to the chassis of the amplifier. And remember, the chassis are connected together through the coax. Not that it matters actually in this particular case, because I would be, even if that wasn't there, when this contact closes, the other relay, and the other relay coil is here, is still going to energise. And this is the other relay coil. This is inside the amplifier, that relay coil. And those contacts that are on this side, I won't draw it, but it switches the amplifier in and out of circuit. So it switches the drive into the amplifier and the output of the amplifier to the antenna, and when it drops out, it connects the antenna to the amplifier input. So that, because that's a negative 18 volts from the bias supply, that comes along here. This is a voltage-free contact. All that needs to happen is that this is connected to ground to pull some current through this relay coil and energise it. In this case, this point's being pulled up to 0 volts because that's a negative voltage, and the power amp operates. So, as I said, probably shouldn't have drawn that line in. Actually, it's probably a little confusing, but that doesn't really matter. Because that's sort of isolated from that anyway with regard that. You see what I mean? So that's the arrangement. So this is inside, that's the FT450. That's the blue relay. And that is the linear amp. Okay, so I hope you found that interesting or useful. As always, thanks for watching. There we go, see all of it there. They are connected together through the coax, but don't worry about that. That is not important as far as the switching goes. Actually, yeah. They are connected together with the coax. So if you connected it together with the coax and then try and put this line on there, it'll go up in flames. If you didn't have the coax connected, then it wouldn't, but it wouldn't switch either. Either way, it's not going to switch because it's a negative voltage, not without that relay. I hope that makes sense. Right, as always, I did better throw in this is amateur radio, because that will then save me doing the video again. Okay, thanks for watching. Catch you next time.